Good morning and good afternoon, and welcome to this second video on Newton's laws. In this video, we're going to quickly examine Newton's first law, and then if you're in my sixth grade classroom, you're going to be asked to watch some videos on the slides presentation that is on Google Classroom. So this video may be a little bit shorter, but if you're in my classroom, make sure you watch those videos as prescribed, and I'll show you what those are. Alrighty? So, what is Newton's first law? An object at rest stays at rest, and an object in motion wants to stay in motion unless acted on by an external force. Alrighty? So, how many people here have ever been to the grocery store? And how many people watching the video have ever been to the grocery store? Now, when you first get to the grocery store, I'm sure that whoever you were with started with an empty shopping cart. And initially, that shopping cart was easy to turn, right? Easy to push and easy to move. Then, as time goes forward, all right, items start getting loaded in the grocery cart. And when it gets full and heavier, it becomes much more difficult to push, much more difficult to put into motion, and much more difficult to steer and move around. Why is that? Well, if you're thinking, well, because it's heavier, you're going the right direction. What is happening is, well, one, the weight of it, right? The weight of it says, I want to stay put here. Oh, okay, you're pushing on me now. Let's move that direction. I'm going straight. I want to move straight. I don't want to turn. If it's going to be turning, it's going to be hard for you to do that, so you have to put more force into the turning, right? That's because an object wants to stay at rest, and an object in motion wants to stay going that direction. All right, so let's look at this in a little bit more detail here. All right, so first we need to understand what is motion. Motion is a change in an object's position. All right, pretty simple. All righty, if I were to put a ball on a flat table, that ball naturally doesn't want to move. Now, if I tilt that table, what's going to happen to that ball? Well, that ball is going to move in the direction of, well, the way that gravity is pulling it. Why? Because the forces of gravity are working on the ball, and the forces that are suspending it are allowing that gravity to work because they become unbalanced, right? More forces applied for a different direction. Motion can be fast or motion can be slow. All right, as much as you have cars on the highway and you have airplanes, both are in motion, one moving much faster than the other when they are in motion or in flight at normal speeds. Motion can be in a straight line, or it can be a curved path. Think about throwing a ball, or long distance, an airplane, right? Because the earth is round. Motion can also change when other forces are acting upon it. All right, so it's a pretty neat idea there, and it goes back to the idea that, again, an object in motion wants to be in motion, an object at rest tends to stay at rest. Now, what would happen if you did this? If you were to go far into space and travel far into space where there is no longer any forces of gravity, okay? We talked about gravity a while ago. The further you are away from the object, right, the less you feel the gravity, because gravity is a pull the closer you get to something, okay? So believe it or not, the further you get down into the ocean and the deeper you go, the more gravity is working on you. Think about that one for a second, right? But if you were to go away and then you were to throw a ball, alrighty, into that nothingness, into that vacuum, that ball would not stop. It would not stop. It'll keep on going and going and going until when? Something else acts upon it to make it change its motion. All right, so Understanding inertia. Inertia equals resistance to a change in motion. In other words, that shopping cart resisted going forward when you try to push it when it was full because it wanted to stay there. It resisted that change. Now, the lighter something is, the less force it takes to get that change to happen. All objects have inertia. I don't care what it is. All objects have inertia. Even the air around us has a certain amount of inertia with it. It's just other forces act upon it. Cold air, dense air, air moving, so on and so forth. And as I just mentioned earlier, more mass equals more inertia. More mass equals more inertia. That's why in the movies you see a car driving through a glass window when the robber tries to break into a bank. Or when you see a car crash, right? That car doesn't stay together. It crumples up and absorbs the energy, right? Inertia is the reason why seatbelts are so needed. All righty. So look at the information here. All right. Seatbelts are required to kind of help us from keeping moving forward. There are some really horrific things that happen when people don't wear their seatbelts and there's an accident. Speaking from personal experiences, no matter how strong you are not going to be able to keep your body from moving in the event of a head-on collision or worse. All righty? All right, so let's just say like this right here, right? We could do some math and say the force on a 160-pound person, right, is about 200 and and this is in the event of a crash, it looks like at 30 miles an hour. All right, so for this example, they set a crash scenario up for going 30 miles an hour. The force being applied to a 160-pound person is 24,000 pounds. That's 150 G's coming to a sudden stop. All right, so that chair is going to want to move. The body is going to want to move. All right, and you're only allowed to move a certain distance because of that seatbelt. Now, if you aren't wearing that seatbelt, sure enough, you're going to be flying out of that car. All righty, and you're going to be leaving some, stuff behind there. So you don't want that to happen. That's why it's necessary. All right, so that helps explain how inertia works. Now, there are some videos that I'm going to have you guys watch. If you're in my classroom, please go ahead and watch these videos. The first one is on the McLaren tablecloth trick. Alrighty, and that's a really cool video to watch. That second one, let's not play that. There we go. The second one is Mr. Xavier Worthy setting a combine record at on the 40-yard dash. But what I want you to pay attention to here is, why does he keep on moving? Now, if you're thinking he's moving forward because he wants to celebrate his good run, you're absolutely right. But why is it runners don't just immediately stop running after a full tilt sprint? All right, and then let's see here. Next, we have, how do satellites get in orbit and stay in orbit? That's a really cool one, and that helps explain inertia and helps explain that other forces acting upon things may cause other things to happen to those satellites. All righty, so make sure you watch that. Now, if you are in the classroom, I'm going to ask you to do activity 2. And part of activity 2 asks you a question, and then I'm going to be passing out a card to every single table in the room after everybody watches the video. And when you receive the card, you're also going to receive an object. I would like for you to put the object on the card and slide that card around kind of slow to see what the object wants to do. Then, real quickly, I want you to slide that object or even flick that card real fast. Make that card move and see what happens to the object. Alrighty, so that brings me to the end of this presentation. Make sure you watch the next video in the series where we look at, I believe it is force. Let me make sure that's correct here. Yes. Definitely looking at force. So, thank you for watching.